Yeah, so I'm Jordan. I'm the co-founder, CTO of Astria. I will see if I remember which direction. Yeah, we'll do a little presentation here. Kind of format here. Plan is like half demo, half some slides that I talk about. So to start with, does everyone here have an idea of what Astria is and does at like some high cursory level? No. Okay. Well, I'm going to talk about this from the perspective of I'm a rollup producer. Like I'm creating a rollup. I've decided a rollup is right for me. How am I going to ship and like why would I want to do this like shipping a based rollup and what is that process, the whole development lifecycle and how we're thinking about it and trying to make it really easy for people. And hopefully along the way figure out what Astria is doing. So to start with, get an idea of like what is a based rollup. This is out of Justin Drake's paper. Rollup is said to be based or L1 sequenced when its sequencing is driven by the base L1. How does that relate to Astria? Well, and then we have this here as well that was, based rollups. The idea that like this the paper that Justin Drake put out, people like, oh, based rollups are cool. I think Arbitrum started out trying to build a based rollup, and then they realized 12-second block times aren't really the UX that we're going for when building rollups. So you needed to add a secondary sequencer on top of it. Some people probably smarter than me were like, based rollups are a great idea. If Ethereum had 2-second block times, and it would be great. And it's like, especially if it had single slot finality. It just so happens that that's exactly what we're building. And so what does that kind of look like from a just like diagram flows before we get into like software architecture? So the Astria shared sequencer exists here. Users can submit their rollup transactions into that. You get this one ordered block because the key on how this works is that we defer execution. So instead of having to execute across every state machine on top of this, we just provide an order for you. And then that data is posted to Celestia, and the way you interact with the sequencer as a rollup allows you to get the data that's only for your rollup. That data is posted to Celestia, and then the rollup can read that data, execute it, figure out its state root, and then you can do what you want to do for posting that state root somewhere. I don't currently have strong opinions on that. I mean, we can talk about the future and being able to do ZK rollups of doing ZK proofs as your state root. The important aspect here is that if you have a given state machine and you have a given set of transactions, it is deterministic, the state root you will arrive at. Then it's just a matter of figuring out that you ran the right state transition function in order to achieve it. And so this is kind of where Astria started from. Is this based aspect is that the rollup reads this data directly off of the block and is able to rely on that. And what that provides you is a decentralized network for these as opposed to a single sequencer, because we don't have a fancy, a fancy virtual machine built into the state machine. We can do this much faster and give you your 2-second block times. So the question, I guess to go back real quick here, I wanted to say like, how does this relate to us? Well, Astria is an L1 with that posts data to Celestia for various rollups, and it's built for you to do base sequencing. So it's a L1, it's a rollups built on top of it are based rollups basically. That's kind of how it's architected from. And there's other options you could do, but this is the way it's kind of intended to. So you've decided you're an app developer and you've decided like, okay, I want to like build something here. And the question here is, can we go through the SDLC of this? Like, what am I actually doing to build it? This is, if we go back to this point, one of the issues here is like, well, why you want single slot finality, why you want 2-second block times is like, when you have single slot finality, it means that I, as the rollup producer, no longer need to figure out how to deal with fork choice rules. If you look through Optimism's code base, I would estimate about 3/4 of the OP node is dealing with Ethereum fork choices. It's also not great for your users if like the order of the transactions, and it's a complicated problem for a rollup developer. And it leads to most of the rollups today we see are like, oh, it's an OP stack or it's an Arbitrum. It's like, it's one of these things because it's complicated and difficult to build. I'm not, as a rollup developer, be like, I'm just going to go redo that. That is I need many engineers and many time. I'm interested in deploying an app. And so I'm going to go with what exists. So you don't have to do that with this. instant, improvement. We have, this is kind of, some boxes and arrows. Josh has done some talks about boxes. We have 6 boxes. But as a rollup developer, the components that you're working on are this actual rollup, this actual state machine. We have provided in order to make this development. I'm interested in building my app. I'm interested in building whatever's uniquely mine. You can focus on that. These 2 components that we call the composer and the conductor can fundamentally be thought of as the write path of how the data gets through, and then conductor is actually kind of like the extra special bit here. When you want to go and you want to build a rollup and you want to integrate with Celestia, there's questions of, okay, I need to understand how to read the data off of Celestia. I have to understand how to post it, how to verify it. If I'm using a separate sequencer, how do I validate that it was sequenced by the right entity? Conductor does all of this already for you, and then has an API integration with your rollup, kind of akin to like ABCI, but right now it's called the execution API. It's designed for your when you have a based sequenced rollup to really just be as simple as possible, entirely state machine agnostic, as opposed to what we have as like the norm. If you work in OP Stack, that their execution environments use the engine API, which is the standard for Ethereum chains, and the Comet Cosmos chains use ABCI. There's a lot of bloat in there that you don't need when you're building a based rollup. So we made this similar to the whole system. You can do it in a different way. We've built rollups that are, we've built a minimal. We did a proof of concept integration with Cosmos chains. We have a Geth integration that we're actively maintaining and building on top of. And then we have also done, proof of concepts of fun, like what if I wanted to do my own fancy, unique state machine? I wanted to do something like that's not normal blockchain, but I want to use blockchain as like a database storage layer of some sort. Like you can also do that. And so all you have to focus on is like this and your application. If you're a Solidity dev who wants a rollup, our Geth implementation, soon to be added in, but like already being used by Forma, is like a pre-compile manager. So you can like write your own custom pre-compiles for your Solidity so that you can enable your special app behavior that's maybe not normal to every EVM in the world, which is great. But like, how do I actually build that and test that and run that locally? And so the classic developers. I'm going to go ahead and kind of exit out of the slideshow view here real quick so that we can look over some stuff here. We've built this. Let me make this font bigger, and then we'll just clear here. All right. So we have built the Astria Go CLI. This is, it is in a classic Web 2 sense. There's a lot of tools like this for you to go and integrate with. If you're building a new Web 2 app and you want a database, there's things like Firebase, and you run something locally and you test it and then you ship it to prod, and there's this easy promotion cycle. So that's what we think about when we think about how are we building and shipping these. So with the Astria Go CLI here, this is going to run all of the core Astria components locally on your machine, such that you can do your hot reload cycle of whatever your rollup app is. You can go and say, oh, I'm going to change my pre-compile and reload Geth. You're going to say, oh, I'm just going to run Geth and then also push it down. So we can do, with this, I've purged everything, so I'm going to initialize. I didn't think about the Wi-Fi problem. This might take a minute, but they're not that large. When you initialize here, it's actually going to pull the binaries of everything that's going to be run as a sidecar. And once it's loaded here, we'll be able to, and I'll come take a look once it's finished here. Once that's all loaded, we'll be able to run all those components. In the meantime, we can go. We have this is our Geth fork, which is published. There's a website you can go and see the changes that have been made. In here, we can just start our, I did like a make Geth earlier. We have some fancy just commands here. I think it's just run. Yeah, I think I run this. I think actually I need to just init because I didn't initialize my Geth node. Just clean. Maybe I did, and there we go. Cool. So we have a Geth node started up, and then once we get the this is running, and then once everything else is started up, it will run against this, and we'll be able to see just even through the CLI here that everything is going. So Astria go dev run. Yeah. So we have, I showed you, we have a sequencing node that is, spun up here. We can see consensus operating through Comet BFT, which is, how our sequencing node works. And then we have the composer and conductor nodes here. And we can see that this is firing into Geth, creating new blocks locally. And I can go and I can just do a hot reload. I can go and I can make some modifications to what I'm doing and do this kind of whole dev cycle. It's like trying to make it as easy as possible for you to locally build. And he's like, but like running Astria, I'm gonna have to figure out how to run it. It's like, no, there's tooling for you to build and test on your local machine. And this is, this is a simple, our first pass of this, you talked about using dev cluster in the past. Like we also have fancy Kubernetes and Helm charts, and you can do all that. But when you're doing a lot of like local development, you oftentimes don't want to like rebuild the Docker image each time you want to test what you're doing. And so this will work. And the cool thing here too is that like we're running Geth, you can run any rollup against this as long as it implements the execution API and a couple of integrations for submitting the transactions. You are like fully set, and it will go and it will run through. And so that's, okay, now we can go and we can build, and you see like, oh, like composer and conductor, they like stopped being able to communicate with the client we had. Yeah, so that's, the build process. And hopefully that's useful for people. We go back in here. That's great and all. The question then in our software development lifecycle is I have built something, but I actually want to deploy it. This is oftentimes where things become more complicated. I should go ahead and. All right. Yeah, so when we get into deployment process, this is, again, in a traditional, this is why some people might prefer to build just on top of main ETH. It's like, oh, well, what's my deployment? And it's like, oh, I push a Solidity contract, I pay for it once, it's deployed to a network, and I don't have to worry about running nodes. And so how are you as a rollup developer? You've decided a rollup is right for you. How do you work with this? And again, we come back to this, is like, well, that looks like a lot of things that I have to run. We built some automated tooling to do it on your machine, but when you go and you deploy, you're like, okay, I'm gonna have to figure out how to do AWS. Am I gonna like pay for services? Am I gonna have to coordinate with other people to run all of this? So there's a couple answers here. One is that like we have a lot of in-house expertise on this. At one point, we had this like one-click button, deploy a rollup. This is how a lot of people are building rollups today. They're using Conduit, or they're using Caldera, yeah. And this is how lots of developers are getting into running a rollup. We'll help you run your node. It might not be a one-click, because it turns out this one-click isn't actually all that valuable. As we find, people want to do things like customize their pre-compiles and have custom images and build all of their fancy stuff. But we can help you run that infrastructure. We currently doing this with Forma and their mainnet. And I can talk about how that kind of works here a little bit later. But also, we have, again, to the point where I said before, we have all of this fancy Helm charts and Kubernetes and all of that, which is really useful for testing your deployment. You can run things locally, you can test, you can do CI/CD if you're interested in running that. We have all of this built. It's how we're going to deploy it ourselves. So coming back to that point, I set up today, like last night here, I went and I set up a new rollup, and I'm kind of going to run through. Is like, okay, I'm running a rollup. I want to test this, not just on my machine. I want to test this. I want to see, how is this going to run against testnet? Where is that data getting posted to Celestia? How is all of that working? And so I have running on my machine right now. If we go over here, there's a whole bunch of things that are running. It was like one command. It spun up a bunch of stuff. We have Celestia Mocha light nodes. We have some block scout stuff, an EVM. We have all this stuff running. And so right now, if I go on my machine, when I spun that up last night I came up with a rollup name, and I'm posting data. This is actually running directly live against our current DevNet off of my machine and posting data. So we've worked with the people who built Selenium to build Astria. And so you can come here, and when you have rollup transactions, which you can see have gone through here, this is like a local dev thing. If I reload the page here, scanning for new transactions, we can go back to our main page here. Let's say we want to fund a wallet just to show like proof of like, hey, this is actually doing something, right? Build a whole new address. Let's go to our faucet that's running. This is running on my local machine. We can request some funds from our faucet. We can go here into our Explorer. We see one more transaction has come in that executed. It's like, okay, that's cool. This is all running on my machine. But like, what's happening further down the line? Well, we can go and we can look inside of Astria. We can go into the rollups page here. Some work on making these more readable, but this is the newest rollup that was created and the data that's been posted to it. We can see the actual sequences of data. There's a bridge account that we'll talk about a little bit later here. So we have all of this information. It's like, okay, this is cool. Additionally, we have a link directly out here. The way that I go over how we post data to Celestia here. This was also posted to Celestia's Mocha network. Again, pushed to the test net, pushed to the network. We can see kind of the bytes that come here. One of the unique things about building on top of this like based rollup architecture in the way that Astria is built is that if you are running a normal OP stack chain, you have empty blocks, you're still posting data. There's a cost. If you have no users, you can see here, this is all of the blob commitments that have been posted. If you have no users, you have no data to pay for and post when you're running this manner. So there's infrastructure cost potentially of running it. But because of the way our shared sequencer works, there's two types of data bundles that we post and two namespaces. One that contains some metadata information that's usable by everyone using Astria. Those get posted and it's an overhead cost to the sequencer now. Those get posted every block time of the sequencer. The second is your rollup namespace data. And so that gets posted here. There's, all of this is fancy. It's protobuf, it's batched. It's compressed with Brotli so that you're using fewer bytes. If we look here at this namespace, there's 3 kilobytes of data here versus 3.5. These have been all minimal transactions. There's not a lot of batching that happens in compression, but when you get high transaction flows actually coming through, you can start to see that there's higher compression coming through in terms of the data that actually gets posted. And so you can trace this throughout the stack. We also have, I don't have it set up right now. We're working on getting it fully integrated. There's a CLI tool because we have this data posted to Celestia. I was like, okay, like there's a downside potentially to this. I want to see what the actual data is. We have a tool such that you can like copy the base 64 and go like see what data was actually posted for you because it's batched, compressed, protobuf data. It's not always the easiest to insight into. But yeah, if we go in here, and I would have to reboot the testnet faucet, but like if we went, we can actually see here, this timestamp here. This was created 3 minutes ago or whatever when I actually created that transaction that goes in. And so this kind of flow and all of this tooling, again, single line command. If you have a Kubernetes cluster, you can just run it. You just have to have your Docker image and you're set to go. And working especially one of our next steps is how do we take this CLI where I had everything configured, there's some configuration there, had it set up exactly how I liked it locally. How do I then go into the production mode and do that? You can test with this setup, you can test all of the Kubernetes stuff locally as well before you go, and you can have the normal staging flow of launching your software, testing it, and pushing things through. Yeah, so that's kind of, how do you deploy? And then there's the actual problem of like, now I have a rollup. I need money on it because I'm either, you could be a sovereign rollup and, go like the full sovereign, create your own token and do that at day one. But in all likelihood, the way that we see people using rollups today and the way that, for instance, like Forma works is you want to use it, whatever ecosystem you're in, there's upsides to using that same token. So it's, in our instance, like how am I getting like TIA on my chain? But also maybe the question of like, how am I getting USDC on my chain? And how am I going to get, some restaked asset that matters to me? What if those are what I want? And so we've built a bridging solution into Astria that gives you this native deployment. So if we go back here to the rollup here, you can see this like initialized bridge account. And if we look at Block Scout here, you can actually see like the first transaction here is a bridging transaction. I moved from a sequencer account, which had funds, directly up into the rollup, and it gets 100. In this instance, it's a native asset to that sequencer of RIA. On our testnet, you'll be able to do this with Mocha TIA. The sequencer is IBC enabled, so you can get assets via IBC into the sequencer and then use those as your native asset with a native bridge that has various aspects of being able to be upgraded and multi-sigs and change the multi-sig and all of that that you get out of the box when you use something like OP Stack. And also because of the way this is built fairly generically, there's some customization that has to be done on the withdrawal workflow, but for getting the money actually into your chain, it's entirely generic in the aspect of how it goes up there. So it's up to you if you do something wholly unique because your specialized thing is that you know how to build the greatest state machine that's ever lived, and you have the next best thing for execution environments. Like you can customize that to as long as you can process a certain set of protobufs and figure out how to execute and process that. It says this money goes into that account, then you can do that. Yeah, and there's also to that point a withdrawal functionality here. We have a contract solution for this on the EVM. So I transferred some money and did a faucet into this account. And then I have this contract that we created, and then I bridged out, and we're running the tooling to kind of relay and post that. It was a small amount. If I actually click on this contract amount, you'll see that it was, exactly one like NRIA that bridged out. But if we go and we look on, we can go into AstroTrack here, and we can go and look at, view the transactions. There's some stuff we're working with them still on getting us all categorized under your rollup right now. Mainly the sequence actions show up, but you see the bridge unlock here action, and you can see when you look at this, you can validate. If I open this transaction, you can go and say, oh yeah, I can see that I actually did this and I unlocked and I moved it into this account, and it has a balance. This account didn't have a balance; it was created fresh from scratch. And so you have this bridging solution, and one of the things that's maybe not wholly unique, but that is cool about it is also that you can register multiple assets to bridge through this native bridges. It's technically deploying multiple bridges. But so for instance, on this EVM, I could deploy I could have my native token that I take up here, but I could also say, oh, there's USDC coming through the sequencer. I want that as an ERC20 on my rollup, and you can get that all by building on top of Astria. You get the bridge out of box.
Question at this point: where are people bridging from? So is it specific chains or?
So it's going to, it depends. So for instance, in our use case with TIA, and this is where we're IBC enabled on the actual sequencer. And there's also a one-hop solution here. Limitations of getting everything ready for demo here, but you can do a one hop of, and we've done this with like Celestia. You're like on Celestia and you say, initiate an IBC transfer. We have a website we're putting together. You can just sign it with your Kepler wallet and it will send it straight through all the way to your rollup, but it'll do the IBC hop into the sequencer and then automatically deposit into your rollup. And similar with doing withdrawal, you can withdraw straight back. So it's going to depend on the asset. For instance, if you're talking about USDC in the IBC space, we're talking about having that USDC is ultimately going to originate from Noble. So it's depending on where your asset comes from through standard IBC hops until you get into the sequencer, and then as I've used this analogy before that a base rollup is kind of like a materialized view on a database, which is I want to take some subset of that information that's stored there and I want to execute it my own way. We just provide a way for you to very easily shard that, access only the data you need, and then execute it and get your access to the funding and whatnot.
I have to say, describing it as a database for you has to be release a cool pitch for LTL.
Yeah. So sorry, I am a boring person. That's potentially my crypto flaw, is that I think of things in like my Web 2 days.
No, you're right. No, I come from Web 2 data. Yeah. The reason I ask is we're thinking about launching a token and then sort of bridging. That's after we launch the rollup and bridge it on. So we're not sure at the moment we'd launch the token through layer 0 when we do elsewhere. So yeah,
Gotcha.
I'm curious to see what it's about.
Yeah, it would be interesting to talk separately about, we want to do a later native, but have the bridging out. That's something that I don't know that we've thought a whole ton about, but it's definitely possible with the architecture. So yeah, so going through here, sorry, to go back to like what do people need and what are the solutions we provide for here. So bridging, it's like I think with these three, these are kind of the table stakes of what's required for you to get a roll up. There's also, though, there's going to be additional integrations, and I say integrations here, that the idea here is, and this ties into the interoperability of utilizing a based sequencer and kind of, to be really nerdy, using like a shared wall clock time, is that you get some fun interoperability aspects here, which is if my rollup posts data at a certain point in time, I can decide as rollup as like whatever my rollup is, there's some other partner that I want to work with. I also want to ingest their data because I'm interested in that. That affects our users. And you can have this kind of interesting aspect of, oh, here is a rollup which aggregates this sort of data, and it's going to happen at the same block time. I'm curious about what's happening there because I want to do this. You can build that. Additionally, we are like actively working with Skip on working with now Skip Connect, formerly Slinky, such that Oracle data will be available out of the box to any rollup who wants to run on top via the Connect integration. And so it's like, okay, there's some of these additional integrations that, because it's useful to all rollups, we can post it, and you can choose to utilize that data based off of what works best for you and your ecosystem and projects and products you're building. And then I have this last one here is kind of a tongue in cheek, because I think this is what people in like the rest of rollup land do, is they say, well, we did all of that and it's very successful, we're going to decentralize. But if you build on top of Astria, that's already done for you. Because you already have a decentralized proposer, and you already have that aspect done for you. And building from the ground up with that is like, we're building blockchains. Why would we be here if we weren't interested in decentralizing our infrastructure and setup? And so you get that from day one. Liveness guarantees and improvements over running a centralized entity, and not, I'm sure Optimism and Arbitrum and folks, they have some designs. I don't talk enough to them to know, but I do know that it feels like this has taken longer than it should. Yeah, that's all I had here, I think. Yeah, that's the end of my slides here. So kind of open up to questions people have, and try to answer things, and maybe some more demo stuff I can do for you folks if you guys are interested.
I wanted to ask about Forma. How does your partnership work? You guys run the infrastructure, and like how does the fee split and all that work?
Yeah, I think so. I think the answer, in terms of like fee split and whatnot, I'm not going to have the full answers there for you, unfortunately. But in terms of the partnership of how we run, and then there's also, I feel like, the open question people have asked, and I've seen people ask of like, how is Forma on mainnet when Astria is not on mainnet? And so like I can kind of address both of those. So one of the cool things about this architecture from the aspect of Forma's mainnet is that, because at the end of the day all of your data is posted to Celestia, the thing that makes like Forma mainnettable, they are actually operating on top of, for right now, they're operating on a custom running instance of our DevNet. They have 4 different validators that are running for that node, and then the data is posted to Celestia mainnet, specifically for their rollup, and that data is going to be there, kind of available in perpetuity. Well, not in perpetuity unless you're on an archive node, but like that data will be available on Celestia mainnet for you. And so when you go and you say, okay, I want to like upgrade to the newest version of sequencer, when Astria hits mainnet, there's this upgrade path of, okay, now I want to like switch. Similar to when we run things and test things locally, and I do this oftentimes when we're doing and shipping a new test net. or like a new DevNet. I'm like, oh, I want to upgrade I want to get my rollup out, but there's some like initial state that I want to have there. And so we'll do some establishing and going and building like, okay, here's the initial state setup. And now we're going to launch it fully, but I can do this sort of like workflow in the release cycle to be like, oh, you know, as we could see when we looked at the block explorer here, and I did this very much on purpose because you can change what height you're interested in the sequencer at. If we look at this transaction here, this is in block 1. So I very purposefully, I like previously initialized this. I did everything I needed to initialize. This thing hadn't been spun up at all. I can turn this down and spin it back up, and it will resync off of data off of 2 other separate networks. But like at block 1, because I set it, you know, where its block height started, it was first block has the first meaningful data to the rollup. And so with Forma, we can do that process to kind of upgrade to using a mainnet sequencer. Right now, they're a DevNet sequencer, but with assets that are real mainnet assets. Yeah. And then in terms of kind of the partnership and how we work there, I think this is something that's going to evolve over time with different partners. As like the first team we've worked with, we are, you know, we have Kubernetes cluster, we work with them. They're like, hey, we want to do this upgrade. We have this stuff. And we just kind of run their nodes and help to give, you know, general advice and help. It's like, hey, how should I integrate with this new upgrade? Is this going to work? Is this not? And we work there. I think as we grow, obviously that partnership will become a little bit more formal. But it's a little bit, you know, first mover in the space.
Maybe something a bit more technical. I just want to ask about like ordering. How do you guys handle that?
Sorry, what was that?
Ordering.
Auditing?
Ordering the transactions.
Authoring them? Oh, ordering them. Sorry. Ordering the transactions. What are you?
I'm assuming it's not first come first serve, right? Because like.
So right now, and this is one of the areas where we talk about integrations, where we'll continue to build things that are useful for people. Right now, the way that transaction ordering works, it is essentially roll-up driven to an extent, where you have the composer component builds batches of transactions. So if I fire off like 100 transactions into it, it observes the mempool, and it watches for EVM transactions to go pending, and then you can run multiple different composer instances, but like when it finds transactions that are valid and pending, it will push them down. And this, I think, builds into a full order flow pipeline, right? And it depends on what you're interested in as a rollup. If you are a rollup who is interested in having some sort of rollup built sequencing selection, Edom, our engineer who just walked in here, put together a paper on like how you could integrate with Suave to say, like, if I have a Suave bundle, that's always the top of block for me. From the actual sequencer right now, its default, it is essentially first come, first serve. But it's a little bit like there's some nonce stuff. Unlike Comet BFT, we actually do some like nonce ordering so that we make sure things execute in order of received, and it's a little bit more clean. But the long term here is that there's going to be a full order flow setup on top of this, and it's up to you how you want to integrate as a roll up and who you want to work with. Maybe you just want first come first served and you can participate in that way. Maybe you want a fully roll up owned builder, but you want, you know, decentralization of making sure you have consensus over that. Those are, you know, there's options that kind of abound there.
Do you think like, I remember last time we talked, I think, we talked to you guys, you mentioned something about soft finality.
Yeah. So I say, like,
to me, I feel like we just we have the order, right? We kind of figure it out.
Yeah, so this is I think soft finality is kind of and I've been trying to figure out how to reword this, but so we talk about, you know, when we go back to this diagram here, you get, we call it like firm commitments versus soft commitments. And really what you're getting from the data that's posted to Celestia is a commitment of availability of that, because we have a smaller proposer network. But if you get access to the data at soft commitment time, the only thing that could potentially happen to stop that from actually existing is if didn't get posted to Celestia, so that everyone you could verify with, the reduced trust and higher certainty of like data availability. That's the only point at which that's kind of the difference between the soft and the firm. This is different than in ETH land, where it's like, well, the soft commitment, like the order might change. It's like, no, the order is not going to change. It's just either going to exist or not exist. And if we do our job well and everyone operates their nodes correctly, then it will always end up existing. So it's just a matter of, like, soft is potentially like the wrong term here. It's a
For us, we just want to get it like fast enough, right? Just reduce the latency.
yeah. So we run our sequencer, and I think this data is here. We've been doing some like large posting, so it might not show up here. But in Astria, there's some like blockchain statistics. This one doesn't have the block time one yet.
Blocks might have it.
Blocks might have it.
You might have the average. Each block will show it on it.
Yeah, each block will show how long the block takes. You can see like 1.85 seconds right now, running Comet BFT consensus. So like that's 2 seconds is kind of our, like, it should be a bit faster than 2 seconds, just from like a UI perspective. And so that's the soft commitment. We execute those and kind of to the point of like you can integrate any execution machine. This is actually like, it's a protobuf API that anyone can implement. We've implemented on a Geth node to kind of override the normal engine API. When you go in here and you execute a block, that doesn't necessarily add the commitment, but we have this idea of like updating the commitment state. And within ETH, the way that we use this, and this is up to your decisions, but in general, what we say is that when you get a like soft commitment, that is a like in ETH land, it's head and it's safe, and then we wait to mark it final until it's firm. Whereas opposed to like in a normal ETH world, you would actually have like head, and then later you'd have safe, and then you'd have final. So yeah, it's like definitely more firm than what you would otherwise experience. Yeah, any other questions? Great. Well, thanks everyone. It was fun chatting with you, and yeah, hopefully that learned something.